Hello, my name is Ronald Foster, and this is my Physics 1010 Module 2 project, Impact Craters on Earth. So our first question is, what happens to the asteroid's kinetic energy when it hits the Earth and is essentially brought to a stop? Asteroids carry immense kinetic energy, and according to the law of conservation of energy, the energy of interacting bodies or particles in a closed system remains constant. When the asteroid makes impact with the Earth, its speed is swiftly slowed down and is brought to a stop. The speed is now gone, but the energy is not. Kinetic energy is converted to explosive energy, blowing debris of whatever was unlucky enough to be in the asteroid's path away. The shock continues to be felt through the Earth's crust from the trajectory of impact, and some of the Earth is melted away by the thermal energy released when the asteroid is slowing down into the Earth. You can see that kind of depicted here. It goes down, it melts everything in its path, it stops, but the shock wave continues, and then all that stuff that was in its path gets ejected upwards into the sky. And then here we could see a crater that actually vaporized the mountains over here. Just landed smack dab in the center. And the next question is, what were the impact effects and how did they lead to the extinction of the dinosaurs? The, I don't know how to pronounce this, but the Chicxulub crater, which wiped out the dinosaurs, is located off the south side of the Gulf of Mexico. It is so large that you would not know it was there unless you could be elevated to space like in this photo. That is why it went unnoticed for all of human history leading up to the 1970s, when it was accidentally discovered by scientists looking for a good place to drill for oil. There are some disagreements by the experts of the crater as to exactly how the mass extinction event took place, but they have consensus around the long-term effects of the impact. Debris was shot up into the atmosphere, and it rained down like hot fireballs, raising the temperature of the entire planet and causing wildfires all over the world. The shock from the impact caused a 10 to 11 magnitude earthquake, making volcanoes all over the world erupt simultaneously. And fun fact from these two points of data is scientists aren't sure if it was like several, I don't know if it was 1,000 or 100, but there was a long time of fireballs of a few hundred degrees falling down, raising the planet to like 300 degrees Celsius ish, or if it was just 1 minute of really, really hot fireballs, raising the planet to 1,000 degrees Celsius for just 1 minute. But the ash from, oh yeah, and also this volcano is erupting. There's a section of India that was actually covered in magma for many, many years, which is molten magma for a long, long time. The ash from these eruptions blocked out the sun for millions of years, leading to a planetary ice age. The lack of sunlight also killed many plankton, disrupting the ocean ecosystem. Large sea creatures starved to extinction. Land animals that could not hide underground died from the harsh conditions, like the dinosaurs. Many large flying creatures died, but smaller flying dinosaurs would eventually evolve into birds. The land animals equipped for survival were mammals like us, and some of these mammals evolved to be us. 3. If the impact had not occurred, would we be here now? Experts on the crater and its evolutionary consequences say no. The dinosaurs were too ferocious for any mammal to roam open fields like humans. Our evolutionary ancestors would have had to stay in the trees where they were mostly safe. If the kinetic energy of the asteroid was 5.67 times 10 to the 23rd joules, what is the equivalent number of Hiroshima strength atomic bombs, which are 1.5 times 10 to the 13 joules? The answer is the asteroid was the equivalent of 3.78 times 10 to the 10th power joules, or 37,800,000,000 Hiroshima nukes of energy. And then here's a few other pictures of craters. Here's one from Middlesboro Impact Crater, Kentucky. You can see they actually just built a town over the crater. And then see, you could kind of see like the ring, but it's mostly got eroded and just formed like a valley. And then here's one in the Wells Creek Crater, Tennessee. There's Cumberland City. smack dab in the center. And this one, a river even runs through it. You can't really tell, but scientists can find out that there's a crater here based on the types of minerals in the ring of the crater. And then my personal favorite, which I've been blocking, is the Valhalla crater. This is on Calypso, which is one of Saturn's many moons, and it's actually the largest asteroid impact crater we see in our entire solar system. You could see that there's actually multiple rings. There's many, many rings. There's craters inside the rings. But what happens when a really large asteroid hits is a bunch of rings form, where there's the initial impact here in the center, and then outwards a bunch of other rings form. There's actually one like this in South Africa here on Earth, except it's nowhere near as big.